Hello and welcome to our 5 p.m. press workshop, Aware, the most comprehensive meteorological study of Antarctica ever undertaken. Our speakers today are Lynn Russell, climate scientist at Scripps Institution of Oceanography, the University of California, San Diego, Andy Vogelmann, atmospheric scientist at Brookhaven National Laboratory, and Jim Mather, ARM Climate Research Facility Technical Director, GOE Atmospheric Radiation Measurement Climate Research Facility.
So I'm very excited to tell you today about a new campaign to make some very groundbreaking measurements about the meteorology and atmospheric constituents in Antarctica, one of the most difficult places to get to, as well as one of the least studied places in our planet. And this is a collaboration that my colleague Dan Lubin, a senior scientist at Scripps, has put together over the last 5 years. The motivation behind this I will talk to next, but basically this was a multi-year effort in order to get together both the 4 co-investigators listed here who all contributed important parts of the science, including colleagues David Bromwich and Johannes Verlinde, who aren't here today, as well as myself and Andy Vogelmann. And as we note here, this is a joint effort between the National Science Foundation and the Department of Energy because of both the amazing amount of measurements that we're putting together and the extreme logistics that are involved in bringing a campaign to Antarctica. The campaign period was designed to be just over a year, starting this summer. In fact, starting just this month, we're already taking measurements. That's where Dan Lubin is now, and already reporting back results from the West Antarctic ice sheet. And so this is the start of the campaign. The idea is to run most of the measurements year-round through the Antarctic winter and through the following summer, through January 2017. Why are we studying in Antarctica? In part because there are important warming that's been observed at the surface of Antarctica, and here's just one example from the Nicholas and Bromwich paper in 2014, where they report the warming trends in different regions of Antarctica measured by surface measurements. And as you can see, West Antarctica and both, as well as the Antarctic Peninsula, are regions where the warming has been highest. So this is the West Antarctic ice sheet here, McMurdo's down here, and these are in the region of 0.2 to 0.4 degrees Celsius warming per decade. So these rapid rates of warming are one reason why we'd like to understand better what the atmospheric conditions are and how the radiation balance is changing in Antarctica. So the motivation more specifically is that West Antarctica is one of the most rapidly warming regions on Earth. Its warming is closely linked to global sea level rise, and there's a known potential instability in a warmer climate to lead to even more sea level rise. Its rapid warming also does not have a comprehensive explanation. There are a number of hypotheses about why and what's contributing to that warming. However, unlike Greenland, it does not show unequivocal signs of atmospheric warming. The dynamical mechanisms might vary with both season and location across Antarctica. And as there's a talk just at 4:30 today by David Bromwich next door, there are likely complex teleconnections between Antarctica and the subtropics and tropics that partially influence the warming in Antarctica. So it's a very complex system where we need to understand more about what's changing in the atmospheric circulation in this region. Why do we not know this already? Well, there's no substantial atmospheric science or climatological work on West Antarctica since the decade following the 1957 International Geophysical Year, and so that meant that that decade of measurements ended in 1967. So there haven't been any measurements characterizing the upper air with balloons or sondes since 1967 on the West Antarctic ice sheet. And so the information is limited to several automatic weather stations at the surface. And so there's a need for observations to understand the details of the surface energy balance. And here's a map illustrating both where our West Antarctic station is, as well as McMurdo, to study this West Antarctic region.
So the deployment that Jim will speak in more depth about later consists of two main sites. The largest one, the largest instrumented site, is sited near McMurdo at the Cosray site, and that there is another rather substantial deployment at the drilling site at the West Antarctic Ice Sheet Divide at the drilling site there. These are separated about by 1,600 kilometers. Basically, the waste divide has still a very impressive complement of instruments, but of course, due to logistics, you couldn't move everything similar to what you have in McMurdo. So what I'll be now talking to you about is some of the specific objectives that we have for the waste divide and for the McMurdo deployments. We're first going to start with McMurdo deployment itself. As Lynn mentioned, we're underway at this point, and it'll be going on for another 14 months. The main objective there is to get the detailed cloud and aerosol observations with the most advanced atmospheric science equipment available today. And in the lower part of this slide, you see examples of some of these instruments. I won't go into the specific details, but I'll say that there is a LiDAR and a number of radars that are operating at different wavelengths. The key thing is that by using these different wavelengths and folding them into the same picture, each one of them tells you something a little bit different about the cloud structure and the cloud microphysics. Put it all together and you have a very complete picture. This is something that instrumentation that ARM has been developing and working with for some time and has a lot of expertise. And similarly, its sister program, the Atmospheric System Research Program, has scientists who have developed a number of algorithms that designed to extract out the cloud and microphysical information that's there. So the main objectives are to understand the unique Antarctic manifestations of mixed phase clouds and aerosols and their effect on the radiation budget. Mixed phase cloud is where you have within the same volume a mixture of liquid water, supercooled liquid water, as well as ice. And these clouds can form in many different parts of the globe, but they're particularly prominent and puzzling within the polar regions. And then we want to use the most advanced atmospheric instrumentation available to examine the cloud properties. In particular, with regards to Antarctica, this is a very dry and pristine and cold environment. So it's very important for us to understand the cloud physics that's going on with those so that you can understand the overall cloud and atmospheric behavior. Moving now to the waste deployment. This deployment is during the summer field season that you have out there, and we're going to be dealing there with observations of cloud, upper atmospheric measurements, and the surface energy budget. And shown below is an image of the waste camp. And as I mentioned earlier, because you're so remote, you can't necessarily bring all of that massive instrumentation that we have at McMurdo. However, we have a number of instruments that are uniquely positioned there to provide new insights into the clouds. For instance, the image in the middle is a microwave radiometer that's capable of giving you very high temporal resolutions of what the water vapor distribution is in the lower part of the atmosphere. And on the far right is a spectral radiometer instrument The key thing there is that by exploiting the differences in transmissions that you have at different wavelengths, you're then able to extract cloud information that you can then use to understand the cloud microphysics and its impact on the radiative balance. So the main objective is to characterize the surface energy budget and atmospheric profiles of temperature and humidity for understanding the warming mechanisms that Lynn mentioned over West Antarctica. And in particular, there are two key components to that. One is the influence of the local cloud radiative forcing. In other words, how do the clouds affect the long wave and short wave radiation that's reaching the surface? And the second one is the large-scale influences of the subtropical and tropical teleconnections. This is to give you an example of another set of measurements that's being taken at the WACE, which are balloon-borne sensors. These sensors you launch using helium, and on board you have temperature, humidity measurements, and as well as pressure. And the plot here shows some preliminary data of an interesting event that happened where basically what you see here is that you have very dry conditions, and then there is a storm that comes through and basically provides the, oops, you are not able to see the pointer. You have these dry conditions, and then a storm comes through and basically bulges out, and it dominates the lower part of the atmosphere with this new intrusion of moisture, which has an impact then on the energy balance before then returning the day after. So with that, I will now turn things over to Jim, who will explain the deployment.
Before I get to this map, I want to point out that the plot that Andy just showed of those the upper air humidity is the first measurements of that kind in almost 50 years. So it's really pretty exciting, the measurements that we're already starting to see out of this deployment. ARM is an observation program, as has been pointed out. We've been operating since 1992. And I guess the one thing I want to impress with this slide is that we do have some experience operating in difficult conditions. We provide observations of the surface energy balance. As Lynn mentioned, this is what we need to understand the surface energy balance, to understand the warming in this region. And we also measure the components of the atmosphere that affect that balance: cloudiness, aerosol properties, water vapor, et cetera. ARM provides these observations, these data to the public to support research. We work with the entire climate research community, but we have a particularly strong relationship with the DOE Atmospheric System Research Program. And I want to point out Shaiman Nasseri, who's in the front row here, the DOE Program Manager for the ASR program, in case there are questions later about that. But I want to point out a few things about this map in the upper left. Shows where ARM has made measurements over the last little bit over 20 years now. The speckled balls indicate locations where we've been for an extended period. Our first site was in Oklahoma. We've been there for over 20 years. We're in Barrow, Alaska now for going on 18 years, and so we do have experience operating for extended periods of time and in difficult environments. But our most recent sites are these two deployments in the Antarctic. I should also point out that the large majority of these sites contain approximately the same set of instrumentation that I'll be talking about in a minute. So the comprehensive suite of observations for the surface energy balance and the atmospheric properties are found at virtually all of these sites. Now turning to McMurdo, this site includes approximately 35 sensors to measure surface energy balance, surface meteorology. It includes multiple radars, 4 different radars for looking at clouds, an additional one to look at wind profiles. And as Andy indicated, that gives you a wealth of information about the physical structure of these clouds as well as the content. Also LIDARs, which give additional complementary information about clouds as well as water vapor and aerosols. So a wealth of information about the atmospheric column over McMurdo. And these will all be operating for a year. Additionally, we have a wide variety of in situ aerosol measurements at the surface, including information about cloud condensation nuclei, which is very important for understanding the mechanisms forming these clouds, as well as detailed information about the surface energy budget and meteorology. Again, approximately 35 instruments providing this information. And shown on the right is one of the LiDARs that gives information about aerosol profiles. Now the WACE Ice Camp, this is significantly stripped down physically. There's one shelter. You can see it's a fairly desolate location, but actually there's quite a significant amount of instrumentation here. Really the only difference in terms of capabilities between the WACE deployment and McMurdo, we do not have radars here, and we do not have the in-situ aerosol. However, we do have LiDAR, which provides information about cloud structure as well. And we have information about, quite a bit of information about radiation and meteorology, and importantly, 4 per day radio soundings, upper air temperature and humidity for the course of this campaign. So that'll be an incredibly important data set. Now, it's been mentioned, Lynn mentioned, this is a challenging place to go, and I just wanted to highlight a few points. We've been all over the world with the ARM equipment, but we had to do some special hardening to go to Antarctica. We were told to expect winds exceeding 120 miles per hour, and when you have a radar that's 20 feet tall, that's something you have to pay very close attention to. Sustained temperatures of minus 50 degrees Celsius, again, requires special attention. Just getting there is a significant effort, so all the containers had to come down via aircraft. Very limited flights available. Even more difficult to get out to the WACE site, where you can see here landing on skis there in the middle of the ice sheet. Very narrow deployment window to WACE. We'll be in McMurdo for a full year, a little more than a year, but WACE we're just there for about a month to sample the Antarctic summer. Very difficult to get in and out. And physically demanding. The participants all had to go through special screening to participate in this experiment. And we are ready to get some preliminary results. I wanted to highlight, this is one day. Each of these plots is 24 hours. The upper 2 plots are showing altitude, 0 to about 5 kilometers, and the colors are representing clouds. So the upper panel is LiDAR, the middle one is radar, showing the same cloud deck. And I want to point out a couple of things. First of all, you see this bright line at the top of the cloud layer from the LiDAR. These are very small particles. We're very confident that these are liquid particles, so that's telling us we have a mixed phase liquid and ice cloud. We see these a lot in the Arctic, but knowing that they also exist in the Antarctic is very exciting to see. Meanwhile, you can see this feature here, very different with the LiDAR and the radar. The LiDAR is showing you where cloud base is. It's attenuated here. The radar is showing that we have a much thicker cloud level, and there's precipitation going on here. So just this one image, a lot of information about what's going on with these clouds, and a really unique information already just a week into the deployment. This is infrared radiation emitted from these clouds, and very large swings in infrared being driven by these clouds. So a lot of information beginning to collect. So final slide. So there's been very little information about Antarctica in terms of clouds, and I should have said earlier, these cloud measurements that we'll be collecting from WACE will be the first ever cloud measurements at the WACE site. And in terms of Antarctica, McMurdo, the most comprehensive set of measurements ever taken on the continent. So very monumental measurements at both sites, and the opportunity to learn a great deal from both sites. I should say that we've been operating again in Barrow, Alaska. I've learned a lot about these cloud systems in that region. Very different meteorology, different aerosols in this region. So opportunities for the first time to learn how are these clouds different in this environment. These data are now starting to flow, will soon be available for public use, and stop there.
Okay, thank you. We will now take questions from reporters in the audience.
Yeah, Alexandra Witsey with Nature. Can one of you talk a little bit about some of the specific hypotheses that maybe this data will address? You talked a little bit about these teleconnections that you might be testing, but can you talk in a really physical, nitty-gritty sense about understanding this cloud will allow us to test this idea in this way?
So as we've heard at some of the prior talks here at HU, you have a number of different influences that can basically draw in, impact the Antarctic. For instance, you have the southern annual mode and the issue there of how that sets up different patterns and pathways for things to be coming in, meaning water vapor and warm air sources as well. And this year, we're also starting a very, there's an ENSO event that's starting to taper off, but that also starts setting up these different dynamical situations that basically steer energy in and around the different region, the Antarctic region. So there's basically been questions as to basically how much is, for instance, the global warming and the shrinking of the westerlies, the westerly zone around things, affecting things. Oops. But the effects tend to be more in the Antarctic Peninsula, and they're not as easily able to penetrate into the wastes. And so, for instance, there is QuickScat data that shows that there's basically meltwater events that are happening well into the wastes. And so even with the wastes and the McMurdo, they're affected differently by the atmospheric systems that are passing through the region.
Are there any other questions from reporters in the room?
Hi, I'm Andrea Thompson from Climate Central. Is there the potential to extend this effort beyond the January 2017 timeframe?
There is, for the main facility, not. We have commitments. Typically, we commit we refer to this assortment of instruments at the McMurdo Station, our mobile facility, and that is committed beyond that, so we'll be moving on. The smaller shelter that's at waste, there is that potential. There's actually been a request that we will be considering. We're looking at that. So that is possible.
Any other questions from reporters in the room? Zoe, do we have any questions from the chat? No? Okay, thank you. That concludes our press workshop. Thank you. And that's our final press event of the day. Tomorrow we start up again tomorrow at 8 a.m. with fluctuations within the lunar dust cloud results from NASA's LADEE mission.